Welcome to Homework Lib.
In this exercise, we have a wave function psi of x, y, and z that is given in Cartesian coordinates as a times x times e to the minus alpha x squared times e to the minus beta y squared times e to the minus gamma z squared, where a, alpha, beta, and gamma are positive and real. And in question A, our goal is to find what is the x position that we're going to call x0, where it's most probable to find the particle. So notice that the probability density P of x, y, and z is equal to the square of the magnitude of the wave function. Okay, and the square of the wave function is a squared x squared e to the minus 2 alpha x squared e to the minus beta 2 beta, I'm sorry, y squared e to the minus 2 gamma z squared. Notice that this is equal to x squared e to the minus 2 gamma x squared times a function f of y and z. Okay, and since we want to find the most probable value of x, then we want the probability to be maximized. So in order to find the maximum, I'm going to differentiate the probability with respect to x and search for the point where the derivative of p with respect to x is equal to 0. Notice that the p dx is equal to, according to the multiplication rule, 2x times z to the minus 2 alpha x squared f of yz plus x squared times e to the minus 2 alpha x squared times the derivative of what's inside the exponential by the chain rule. So we have minus 4 alpha x times f of yz, and we want this to be 0. Okay, so I'm just going to factor out 2x e to the minus 2 alpha x squared f of yz times 1 minus 2 alpha x squared, and we want this to be 0. So we want whatever is inside these square brackets to be 0. So we have 1 equals 2 alpha x squared, which means that x is equal to 1 over the square root of 2 alpha. Okay, so this is the value of x0. This is the value, actually, it's plus or minus x0, 1 over the square root of 2 alpha. Okay, since we were taking the square root. And these two are the most probable values of x0. Then, question B asks us if there is any point where the probability of finding the particle in that point in x is 0. So coming back to the probability distribution, the probability density here, notice that this function is only 0 if x0 is equal to 0. It's also true that the function tends to 0 for x going to plus or minus infinity, but notice that in that case, the function is never truly 0 for any real value. The only real value for which the function is 0 is x0 equals 0. So it's the probability of finding the particle in this point is 0.